This is how we migrated a LESS application and the CI/CD pipeline to Helm chart and ship with ArgoCD. I'm going to present myself soon, but who here has been running Kubernetes, Helm, ArgoCD? Okay, good. If I get something wrong, just correct me. But yeah. My name is Domenico Mastrangelo. As Lorenzo, I'm from Italy, another side of the country.
How did you like the pizza?
It was very good. I had the Gorgonzola one, yeah. I'm the founder of Ax.io. We're a small DevOps consultancy agency in Caglianocca. And we focus on on-premises security and compliance. I am a software engineer. I'm a DevOps engineer and the founder and CTO currently of Ax.io. We are hiring. We're looking for an SDR currently and a senior DevOps engineer to cover some clients that we have. And here's a lot of things I like talking about. If you talk with me about these things, I'm going to be happy. Kubernetes, CI/CD, on-premises servers, Proxmox, marketing. I like marketing in world languages. Networking, system design, NVim, infrastructure as code, Golang, Rust, Zig, and assembly language. This is now already jumping in the old setup. This is a company who is very heavy on compliance, so it's a bit difficult to have new things going on. And they set up this platform in 2019. So when they set it up, it was a startup. They just got an agency doing everything for them. And they started small. They started with a Terraform configuration and not much more. Kubernetes was handled also inside Terraform, meaning both spinning up AKS inside Azure and handling the Kubernetes resources. This led to a bit of a mess when deploying, especially after 3-4 years when a lot of things were deployed, changes in infrastructure, changes in the application. It became very complicated. But in the old setup, the developers would push their feature branch to develop branch to merge. Then there was a GitHub action that would be called to merge into staging. And another action will be called to run the Terraform files to proceed with the deployment into the staging environment. For production, it was basically the same. With one small change, the developers had to manually run Terraform from their laptops because I didn't want them to destroy the whole AKS environment. So they had to look the Terraform changes in the eyes and like approve them manually. So I knew that they were doing it manually. Because of course, if you don't know, running Terraform, we were running Terraform auto-apply in staging because we cared, but we didn't care too much because we could always recreate the environment. But if you destroy, if you run changes that will tear down, for example, AKS in production, it will be quite bad. And these are the type of resources that we're running for Kubernetes, so you can define the actual Kubernetes deployment with the replicas and everything underneath. There were some problems with the old setup. It was very tightly coupled with the deployment of the infrastructure changes. Sometimes you want them, sometimes you don't. Rolling back applications was very difficult. You had to manually go in and change them. Issues will come up randomly where developers were unable to deploy a hotfix as fast as they need to. Sometimes not developers, but the POs will need to change something very fast, as startups often do. So workarounds will develop where the container image will manually be changed inside Kubernetes. You will go kubectl edit or k9 edit, and you will manually change the deployment image. Another issue was that Datadog will not keep track of these updates because the way it was installed, it needed to change all the labels and annotations to keep track automatically inside their platform. And this sometimes, if you had hotfixes, wouldn't be done. You have secrets, a lot of secrets and keys stuffed inside GitHub. This would be like to push to the Azure Container Registry to enable that workload to, I don't know, check key vault and things like this, which made it was not automated, so that the credentials were renewed or manually every year or so after somebody noticed and on Teams were like, this is not working anymore. We need to migrate or to renew the keys. And of course, Kubernetes was deployed in a private network behind a VPN. So GitHub also was connected to the inside of the VPN and would be actively changing things, which opened up also some security issues. But yeah, there was also a feeling in general there should be a better way, an easier way, where you don't have to do everything very manually to just deploy some new images. We were called in. We proposed this new setup with Argo, with keeping GitHub, which we had already migrated from Jenkins, actually. They already had Kubernetes, they already had everything. We did, though, package everything up into a Helm chart and shipped it with ArgoCD. Their application is in PHP mainly, some PHP and some Go. And they had a few of them, but we created a Helm chart for each and deployed those. Yeah, so that the developer manual involvement in case of a hotfix or production deployment to converting all the Kubernetes provider resources inside Terraform to a package Helm chart. So you will decouple everything and have Terraform handle infrastructure, Argo handling the deployment of the applications. For those who don't know what's a Helm chart, on the website, helm.sh, it describes Helm as a package manager for Kubernetes. A Helm chart is a package. This is what it looks like. It's just a folder with a chart.yaml templates, which are the definitions of these Kubernetes resources, like a deployment here, a service, a helpers template. This is a Golang template, where you create some functions that you can call inside the various resources to like fill in some variables, like the name of the chart, the labels that you want to maybe replicate, and then we have a values.yaml file which contains all the variables that will be then substituted from placeholders in the deployment chart. I'm going to then show something about it, but this is, if you can see it, yeah, how a values YAML looks like. You can see, you can set, those variables are all custom, they're not pre-written. You can choose whatever you want, you just need to then call it from the Helm chart files. In this case, for example, image.repository, GitHub container registry, etc. The tag will be updated during the CI in GitHub, and then this will be automatically picked up from Argo to create a new release. What's ArgoCD for the people who don't know? Again, from their website, ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. This is what the, let's call it, homepage looks like for an application. This is another screen from this. This is presentation, now called presentation, but it's the application that I created for the demo that we're going to have later. Again, same more or less picture. You can see from left to right the Helm chart, the deployment, the service we defined, the replica sets, and the deployment created, and the pods that are assigned to the current live replica sets. These ones here are the previous replica sets. So you can also revert back to those, but you can see that the pods live are assigned to the latest replica set. This is, if you click on details, you can see some info about the configuration of the chart, but most importantly, the second tab is parameters, which is basically values.yaml. You can override those values in here and save them, so these take over what you set up in the values.yaml inside GitHub. This way, if you have a hotfix, for example, you can just set up the image to a fixed image. Even if you deploy something new, this will be overwritten to always be the hotfix. This way, you don't cause, you manage the drifts. But yeah, do you have any questions about this? I have a small demo to show how this works. Hopefully it works, because I have this. I think I have to move somewhere. Yeah. I have a nice Fedora image inside inside my place to run this, but the time's always okay. Now it's correct. It's 7:13, because if the time is not right, this doesn't work. But as you can see here, everything is already deployed, because I wanted to make sure that it worked. Actually, this failed horribly, like 30 minutes before coming here. So I spent like 15 minutes in panic trying to fix everything. But if we go from the beginning, this is a simple Go application. It only listens to the root here and serves a hello page service, or a hello page page. You can see I can actually increase the size. You can see here, this is the Helm chart. This is chart values, or chart.yaml. This is values.yaml. Service, which you can see has the handlebar templating. This is straight from Golang. Deployment is the same. And helpers is here, you can see define Go Hello World full name. And this is basically the whole function. If contains release name, else this, etc. This will just then be called, for example, here, include Go Hello World, select all labels, so you don't have to write them every time you have. If you have multiple labels, is an excellent example of it, as are annotations where you include them maybe everywhere in your Helm chart, so you can have like application name to be the same everywhere. And then it's packaged with a normal Docker file building. It's from scratch, so it's very little, very small. But this is already actually deployed here. This is the application K9. This is running on K3s on my VM, so it might be a bit flaky, but let's see. These are the pods. And you can see here we have the application. ArgoCD, this actually, if you don't expose it with an ingress or something else, you can just port forward this to localhost and access it locally. I've already done it here, so that's why you can see this page here. And I should be able to use localhost. Oh yeah, there's an ingress. But let's go back here. Here you can see inside GitHub, I have the code here. I already created a package, which is this. Package is just a Docker image build, and this is the workflow that runs. The flow is simply, if I go here into the image, or into the code, and apply a change like hello polar what? Very not written correctly. Okay, git add dot git commit and push. Am I connected to the internet? Yes. Yes, git pull. No result hosting github.com. Okay, I'm not connected to the internet.
By the way, in the meantime,
yeah.
I'm just curious, was it like I see people taking pictures? You're streaming this to YouTube. Is the recording from the same link available afterwards?
Yes, when we're done streaming, I will edit the videos and upload them separately.
Okay.
So if anybody wants to see that, then don't forget to subscribe to our YouTube channel.
Yeah. So I also like something like that, just take pictures, but it's gonna be the full thing. And where it's you edit and then you post it.
Yeah.
Okay.
Regular videos separated into 2 talks.
Okay. Cool.
I'm just trying to reconnect to the hotspot. Okay. So is it working now? Yeah.
I think you could try doing like a manager reinvestment.
Yeah. it again. Git
Just rebase.
rebase.
Yeah. Devops.
Thank you. Okay. So then, if we see here, this has started. This is a pretty simple build and push pipeline. You can see it here. It doesn't have anything really complicated besides like permissions, the jobs to Helm to build for different architectures. It has cache, builds the image and pushes it directly to GHCR. It will take a second, but in the meantime, I can actually put this. Unfortunately, I have to turn my face all the way. Put this here. Put this here. This is set up to auto sync from values to YAML. And values to YAML here will change because, as you can see here, the last step, the very last step, will update here, commit and push values to YAML file. So as soon as this finishes, that will be automatically updated, and I can then show here that this will be replaced. This now is maybe it's easier once it's finished, but this usually takes 2 minutes. Unless GitHub is down today too, so let's see. But in the meantime, if you have any questions. I can actually show you here. Just make it bigger for the ones in the back. Here you can see the last sync has been successful 2 hours ago. And you can see the page that I was telling you about before, where you have your parameters, you have your values file that you specify if you have a custom one, and you have all the variables here, so you can just go here, edit it, and set a new one, and that will be it will be automatically synced and synchronized with Kubernetes. You can see your history here, so you can see all the deployed versions. You can just as easily here revert to it. So you click like the last version good, like the last good version was 3 hours ago. Go here, roll back. Everything will be taken care of automatically. And as another point, maybe, since we're waiting, application is created here, just new app, and you configure it. This one has been configured with a GitHub app application. So here you can see repositories. This one is connected. If you connect one, you have different choices: the SSH, HTTPS, GitHub app, Google Cloud. So it's not too difficult to use. Some people might prefer Flux, for example, or other tools. For me, this ArgoCD is just easier because It has a very user-friendly UI, which I agree you might as well just learn how to use the terminal to do it. But most POs I've met don't agree with me. They don't want to use the terminal. They just want to click rollback and be done with it. So this is very usable by everybody really in the team, especially nowadays with AI. Everybody's doing a bit of everything. And GitHub doesn't like building this one. It took 7 minutes, 6 minutes. So we just have to wait 1 more minute.
Was it like for compliance reasons that you have the image tag in the Helm chart, like in the file, in the version control?
You mean compared to having it in another repository or something?
No, I think the way I have done a similar thing was that there was like a timestamp in the Docker image tag, and then Argo just checked what is the latest timestamp available.
Yeah, you can also do it like this. This is the easiest, in a way, to set up and to wrap your head around. For this is, for example, the workflow we've done for this team, and in this team the developers are not very DevOps friendly in that sense, so they just want to be able, as much as the PO, to go to the Helm chart or to the GitHub repo, modify the values, and commit, and that's it.
Also easily leads to the situation you had with just now, that was that there's extra comment in there.
Yeah.
Because it does the comment.
Yeah, I have to check it, honestly. Yeah. But yeah, this finished. This should now, I can force it a bit. Yeah, it actually was very fast, but it's progressing, and you can see it synced, and it succeeded a few seconds ago, so this is the latest version. All it took was the time that it takes to build it for multiple platforms, but then it saved these people a lot of time in not having to do it manually and in not risking mistakes and similar. Yeah, what we solved, no more manual deployments, rollbacks are as easy as clicking a button in the UI as I showed you. Git is the source of truth, so everything that you have in Git is what will be live. There's no going around it in a way. Both production and staging deployments follow the same pattern. This was huge for them because the production deployment will take half an hour, 45 minutes maybe, depending on the developer time, the developer knowledge of the platform, of how to run Terraform, etc. So this streamlined everything quite a bit. Considerably reduced the maintenance overhead. Also this one, being ArgoCD that goes out of its way and pulls the values of the YAML file for the changes, you can block everything from going into Kubernetes. So the VPN doesn't need to be in GitHub anymore. The Azure, the only secrets that still are inside GitHub are for pushing to Azure Container Registry, and that's just one IAM role given ACR pool, and that's it. Increase deployment velocity. Now, as you can see, you can deploy 5-6 times a day, just the time that it builds and pushes, and then it's automatically live. Accidental drift is automatically corrected. This is also another thing. If you go in and change the image by mistake or maliciously inside Kubernetes, ArgoCD will automatically detect it and roll it back and try to sync it and put the correct one. But yeah, this was pretty quick, but yeah, again, this is me.